Okay, let's look into ISI PEA question number 9 to 12. I think to 13 only. There are 13 questions only in this paper. 2005 paper. Look into this question, beta. It says consider a combination of lock consisting of 3 buttons that can be pressed in any combination, but in such a way that each number is pressed exactly once. What are the total number of combinations possible with the 3 buttons? Very simple. So it says they can be pressed in any combination, including multiple buttons at a time. Mane, you can press one button at a time. So there are 3 buttons. I can press one button at a time. So how many combinations, how many ways in which it can be done? It can be done in 3 factorial ways. That means it can be done in 6 ways. It can be like this, that I press B1 first and then B2 and then B3. B1 first and then B3 and then B2. B2 first and then B1 and then B3 and so on. So there can be 6 ways in which this can be done by pressing the first one and the second and the third, first and second and third. The second thing that can be done is you press 2 at a time. So I press B1 and B2 together. I press B2 and B3 together, or I press B1 and B3 together. So then this means that I can go ahead and I need to select any 2 from 3, right? I need to select any 2 from 3, right? And so I have used this 3C2 out of 3. I am selecting any 2. And then, in this I can go ahead and I can choose them in 2 factorial ways. So into 2 factorial. So this is also going to go ahead and give me 6, right? The third thing that can be done is I press all 3 of them at one time only. So which means that I press all B1, B2, B3 together. Now, in this case, I just have one way because I'm pressing all 3 of them together. So there is just one way. So if I were to go ahead and add this together, I'm going to go ahead and get 13 ways of doing this thing. Okay, but I come to the next question. It says, suppose that there is a correlation, a good question. So try to see this thing. There is a correlation coefficient between X and Y, which is denoted by R. So we know that correlation coefficient can be written as covariance between X and Y divided by sigma X into sigma Y, and this is given by R. Then this says what is the correlation between X and X plus Y. So this is going to be this, right? Now try to see that this, suppose this is named as R1. So there can be any relation between R and R1. R can be greater than R1, R can be equal to R1, R can be less than R1. So any of these can go ahead and hold, and none of them will hold forever, right? So just to give you an example to this thing. So for example, just assume, so I need to, suppose I want to find out the numerator in this case. So if I ask you what is going to be the covariance, what is going to be the covariance between X and X plus Y. So you will tell me this is the covariance between X and X plus the covariance between X and Y. Isn't it? Right? This is going to happen. And if I ask you what is going to be the variance between X plus of X plus Y, so you're going to go ahead and you're going to tell me that, ma'am, the variance of X plus Y is going to be the variance of X plus the variance of Y plus the covariance between X and Y, right? So if I ask you what is going to be the standard deviation between X of X plus Y, it is going to be the under root of this thing. So sigma square X plus sigma square Y. I mean, if you want, you can just play around with R square also. That is going to make things easier for you. And that's also fine for me to kind of handle this thing. So what you can go ahead and do is you can just put a square everywhere, and you can just try to see how this kind of works out in this case, right? Just if you want to ease out things. Otherwise, also you can work around with variance. See whichever. So if variance will be more, the standard deviation automatically will be more. So I can, in the denominator, I can compare the variances also, and I will get some idea about standard deviation, isn't it? Okay. So now just try to think about it. So the variance of X plus Y will be variance of X, right? Plus the variance of Y plus the covariance between X and y. Let's write this down now. Okay, just give me a minute. I think my pen has got discharged. Plus, I'm going to write this as covar xy only. And if I now compare this with the, so this is this part. Now, if you just compare this with the other one, with this r, if I were to compare this with r, then you notice that this is common only. So it does not matter to me for comparison purpose. I am comparing this with this, right? I am comparing this with this. So if you just notice, when if I will be just looking into it, so even if I square on both sides, I will realize that this is going to be sigma y square plus some term here, right? Sigma square x plus covar xy. And even if I have to find out the under root, then this is going to be this under root, right? So the sigma x plus y, this is going to be this, and sigma y was just this, right? Are you getting it? So I am, so if I were to go ahead and I were to square on both sides also, just for the purpose of comparison, you will realize that there is this extra term that is coming in the denominator. There is an extra term coming in the denominator. Similarly, if you look into the numerator, this is covariance of xy and this is covariance of x with x plus y. So covariance of x with itself is becoming the variance of x plus the covariance between x and y. So if you go ahead and you really notice what R1 is, so R1 is going to be the variance of x plus the covariance of xy upon sigma x will be as it is, and sigma x plus y will be under root of sigma y square plus sigma x square plus covariance of xy. Am I clear with that? So you see, there is no comparison. There is no short rule that I see here. Of course, we know one thing for sure, because in the numerator, there is a variance of x that is getting added up. The numerator is inflating. You see this, the numerator is inflating. There is a variance term that is adding up. Variance is always positive. The numerator is inflating. But do you realize that even the denominator is inflating? So because the numerator and denominator both are inflating, I don't really know which is inflating more, right? So therefore, I cannot go ahead and I cannot work because you see here, this is the covariance of xy. Now, covariance between x and y can be positive, can be negative, and can be zero. Can be positive, can be negative, and can be zero. So it can, I am adding sigma square y and I am sigma square x here and sigma square x here also. But covariance can also be positive, negative, or zero. So taking that also into consideration, we don't know which inflates more, isn't it? So therefore, I will say that none of them will be true. Am I clear with it? Okay, come to the next question now. So, okay, let me just open the next sheet. Okay, now let's look into the next question. So this says, what is going to be the value of integration in this? So this is very good and easy question. So this is mod of x. So if I can open mod of x as x if x is greater than 0 and minus x if x is less than 0. So if that is the case, then I can go ahead and write this as -1 to 0. And I can write this as 0 to 1. And when x is negative, then this will turn into minus x. So I'm going to have x plus minus x dx. And when x is positive, then this will remain as x only. So x plus x dx. Right. So this is going to go ahead and give me 0. And this is going to give me 2x from 0 to 1 dx. So this is going to be 2. Instead of x, I will write x squared by 2 from 0 to 1. So this is going to give me 1. So the correct answer to this question will be, I think I've marked it incorrectly. It's going to be 1 here. Right? right? Okay, come to the next question now. So this says you're given a profit function and you're given two equations and you need to find out what is going to happen where the profit would be maximized. Okay. So now just look here. The equation given to me is 6x1 plus 4x2 less than equal to 120. So I can go ahead and I can rewrite this equation as I'm taking 2 common, 3x1 plus 2x2 less than equal to 16. And the other equation that I have, that is 3x1 plus 10x2 less than equal to 180. So now what we can go ahead and we can do is we can just, plot these two equations. So when I look into the first one, I have taken x1 here and x2 here. So if I put x2 as 0, x1 will be 20. And when I put x1 as 0, x1 will be 30. So this is going to be my first graph. Now, if I look into the second graph, if I put x2 as 0, x1 will be 180 by 3, which is 60. And if I put x1 as 0, x2 will be 18. And I can just go ahead and join this. I need to also kind of find the common region. So because this is less than, so it will be towards the origin, towards the origin. So I will go ahead and get this as my common region. So the points that I need to evaluate on is going to be this point, 0, 18. It's going to be this point, 20, 0. And I need to also go ahead and find the point of intersection between the two. So if I try to find the point of intersection, I will get 3x1 plus 2x2 is equal to 60. 3x1 plus 10x2 is equal to 180, and I can subtract. So 8x2 will be 120. So x2 will be 120 by 8. So this is going to be 4 3s are 30, 4 2s are this, and 15. So I will get x2 as 15. And if x2 is 15, what is going to be x1? I can go ahead and put here. So 3x1 plus 150 will be 180. 3x1 will be 30. X1 will be 10. So I am going to go ahead and get x1 as 10. So this point will be 10, 15. So now I need to evaluate this profit function. Profit function is 4x1 plus 55x2. And I need to evaluate it at these 3 points, right? Okay, let me just evaluate it right away, beta. So my points will be 20, 0, 10, 15, and 0, 8. Even before I evaluate these points, let me check if these points are present as part of the options. So my option 20, 0, 10, 15, and 0, 18, these points are not even available as part of these options. So right away, I know that the answer will be none of the above. But suppose these points were present as part of the option. So your function was 45x1 plus 55x2. So you could have gone ahead and just plugged 45 into 20 plus 55 into 0, 45 into 10 plus 55 into 15, 45 into 0 plus 55 into 18. Right? You could have just plugged this. So this would have given you 900. This would have gone ahead and given you 825, and this would have given you 990. So wherever you find the maximum profit Oh, this would have been 825 plus 450. Now this is 825 plus 450. So this would have given you in total. So wherever you are, your profit would have been maximum, that would have been the answer to this question. But anyhow, these options are not available. So answer is none of the above. Okay. I think this point I have written incorrectly here. This point we had found out as 0,18, right? 18. This will be 0,18. Rest are correct, right? So rest are coming out to be the same. This would be 990, but profit would be maximized here anyhow. Okay, now coming to the next question. Oh, that was the last question. We only had to 12 here. Fine. So that's the end of this paper then, beta. And I hope to meet you in the next class with the next paper. Okay, beta. Thank you.